Logarithm with base a. So if you look here, you see log base a of u times v. It's u times v, correct? That can be expanded using the opposite of what we just started up. So when it's m times, I'm sorry, not the opposite, but exactly what we did up above. So if it's a times a, what do we do with those exponents again at the very top? We added them when it's multiplication, correct? So I could take this and split it up, putting an addition symbol in between them. Because that's exactly what we do with exponents. Is when it's a to the m times a to the n, it's the same thing as a to the m plus n. Same true here. What is it when we divide? Subtract. Okay, guys, what was it when we raised a power to a power? What did we do? We multiplied, but that's going to be weird here in this one. But here's how it kind of works. You take the exponent and you set it to the front. So you multiply it times the front. So it looks like this. So, and guys, it's going to be the mirror image on the other side as well. So just rewrite it, except don't use log, use natural log. So it's natural log of u plus natural log of v. Natural log of u minus natural log of v. You take the exponent of the argument, put it in front, so it's n times the natural log of u. Any questions about those properties, guys? Should be pretty straightforward. Let's look what they look like in examples, okay? Well, first thing we need to address is, in this first problem, how do we rewrite the fifth root of 5 as an exponent? This is significant. This can be rewritten as 5 to the 1/5 power. So, log base 5 of 5 to the 1/5 is how we rewrite it. With our newfound knowledge of the properties of log functions, how could we apply that to this particular problem? What do we do with this 1/5, guys? Remember, any argument raised to a power, you always bring to the front. Any argument raised to a power, bring that power up to the front. So now you're left with 1/5 times log base 5 of 5. And some of you guys were saying it earlier. What is log base 5 of 5 reduced to? 1. So what's 1/5 times 1? All right. Got a little bit more people jumping on that one. That's good. I thought the quietness was just a confidence thing, but I guess it's just a normal thing. All right, so look at number 2, guys. What do you notice is in the argument? Exponents. What do you think is going to happen? So it's 5 times 7 natural log of e. Natural log of e expands to what? Log base e. It would just be 35 because log e of e ends up being 1. Guys, what I want you to start doing now, the sooner the better on this, will make your life a little bit easier in pre-cal. Notice that natural log of e always reduces to 1. Natural log and e are inverses of each other. They cancel each other out. Natural log of e cancels each other out. All right, so looking at that, look at number 3. Again, first step is always what, guys? Good. Bring your 15 and your 5 to the front. What's natural log of e? That goes away. That goes away, and you're left with 15 divided by 5, which is? Good job. You could do that, yeah. But I'd like for you to rather you see that natural log of e just cancels to 1. But yeah, he says there's a natural log on top, natural log of e on bottom too. Can those cancel out? Yeah, they could cancel out. All right, number 4. Bring him to the front. Again, what happens to natural log of e's? I think I've said enough, or I hope you guys got it by now. So your answer should be 6. Questions, comments, concerns? Should hopefully be pretty straightforward, guys. All right, let's look at a little bit more in-depth example here. So look at number 8. Log of 3 to the x squared divided by y. And if you look at the argument, guys, you've got to break it down into every single item. 3 times x squared divided by y. So remember when I say that. 3 times x squared divided by y. As a matter of fact, I want to write it out here. That's how it looks. If I was to draw it out, I mean, it's not the best, but it's what it goes by. Use this in order to help you outwrite this. Expand it. So in expanding it, you're going to write a log for each term. 3, x squared, and y. Okay? That's what expanding is. So log base 3 is your first. And it's 3 times x squared. And what do we say? When we're timesing it, how does that convert when we're expanding log functions? Plus. And then finally, we divide it by y. And what is it when we divide? Subtract. You're not quite done yet, because you can't have any arguments have an exponent. So what do you think the last thing is we need to do? The 2 needs to move in front. I don't know what that was. There you go. So again, you take every single item and you split it out. Does that mean the 3, which is just a constant? Yes, the 3 gets split out from the x squared. The coefficients get separated. Okay? So the next one. Well, I don't want to deal with square roots. We always got to write everything as a power. Okay? This is important even in calculus. If you guys are going to calculus next year, this is important. It's always better to rewrite your square roots to a 1/2, 1/3, 1/5, whatever power. So go ahead and do that first. Now you got to be careful here, guys, because the 4x minus or 4x plus 1 is joined together. Okay? It's together under the square root. So that's got to actually stay together when you're expanding. Okay? So you go through and say, all right, this ends up being natural log of, and I actually use parentheses to keep it together. What's the 8 doing? It's divided by 8. So what does that convert to when we expand? Good. One last step. And there you go. 1/2 natural log of 4x plus 1 minus natural log of 8. Number 6. Number 10, which is base 6. So my bad. I saw log base 6 and I was thinking 6 in my head. Sorry. So number 10. The x minus 2 is already together, guys. So there's no separating that. That stays together. So it ends up being log base 6 of x minus 2 squared. And now what comes is an interesting thing, because look on the bottom. How many items do we have on the bottom? 2. We have a choice here. You have a choice. You could either do this. Minus a big parentheses of log base 6 of y. And it's y times z, is it not? And when we say times, what are you doing? You're adding. You could do this, guys. Well, that doesn't really match the other parentheses. You could do this, or know that y and z are on the bottom, so log y should be negative and log z should be negative. Either way is up to you. I prefer go ahead and doing the latter, doing the minus log y and minus log z, because I don't like dealing with parentheses. Because you're going to have to remove it to begin with anyways. So any denominator item, any item that's a denominator, just make sure it has a minus in front of it. Okay? So I'm going to go ahead, make this a lot smaller. Take that away, and look at that. Now you have both items that are on the denominator, both have minus signs in front of it, right? And that's the way it should work. All right, so let's go ahead, lastly, as always, let's go ahead and get rid of those exponents, and we're done. Guys, if your argument is a binomial, trinomial, whatever, please make sure you're using parentheses. You see here, x minus 2 needs to stay in parentheses. Okay? Make sure that it's a log base 6 of both those to that binomial. All right. I'll let you guys do the last one. If I was to say one is easier than the other, I'd be lying. They're both equally just as hard. You just got to know this. And it's the fact that you know one does not mean you know the other guys, so you got to be careful about this. I think a lot of my students have a false sense of security saying, oh, I got expansions down very well, so I'm going to do condensing because it's just the opposite very well too. It does not work. I've never seen that work for anybody, so just make sure we're equally paying attention to what's going on here, okay? And basically you're doing backwards of what you just did, guys. So you take all your coefficients and make them exponents, and then put them all into one log function. So we're going to take all of our coefficients, so this 1/2 now becomes 1/2 as an exponent. This 5 becomes 5 as an exponent. And at first, guys, and I mean you could do it as long as you want, I'd recommend writing it down one step at a time. And it's something I say all the time in math. If you take math and break it down into small steps, it's very simple. It's when you try to do the whole problem at once and make it one step, and half of you are doing mental math, and the other half you're just kind of writing down on the side. Now you're making it harder than what it is, guys. There's space there, write it. I'm not making you write a thesis, just making you write a few, math expressions. So take the time to do it. So then we go through and say, okay, and I'll even take one more step here and write it like this. And then I make that final step of everything coming together. Hard to see, sorry, but it's a z on the bottom right. But you notice both of those log functions? Did I do that right? I didn't, did I? Thank you. Takes a village with me. It does. I'll admit to it. There you go. Everything positive stays on top. Everything negative goes down below, right? Kind of how some people live, by those morals. Stay positive, stay up. All right, so let's go ahead. Same thing for number 3. Take all your coefficients, make them exponents. So natural log of x minus 4 to the 4 minus natural log of y squared plus natural log of z. And they've kind of tricked you in a little way here in the fact that what is going to be on top, guys? The first and last one. And what's your denominator? All right. Your turn, guys. Go ahead. Be very careful. Put the z on top because it all needs to be one fraction. Okay. You're kind of making it because that times 2 could be thought as, hey, it's a log of this. Take that log and then multiply times 2.
No, that was a z.
I mean, thanks. A z. Yes. Okay. I know. I'm cheering you guys on. I feel like a cheerleader up here for the most part, not really a teacher. Come on, guys, we can make it. All right, so let's go ahead and finish this off. And again, it's the way we answer these questions with log. It says to simplify it. So you go ahead and you can do one of two things here, guys. You can do this. Set it equal to x. And then do what we called, I think last time we talked about was fishhook. Circle the base. Bring the hook around the answer. And set it point to 9. Or the argument. So 3 raised to what power is 9? So actually your answer is 2. Or you can do what we asked, what we've been saying, which is this. 3 raised to what power is equal to 9? This does that for you. However, if you don't see it there, you can just see the log 3 of 9. 3 raised to what power gives you 9, and you know it's 2. Okay? All right. That's nice. What about a square root? Well, you got to remember, guys. What do we do with square roots, guys? Please get a habit of doing that. When we're dealing with exponential and log functions, get a habit of seeing a square root and immediately changing it into a fraction exponent, okay? Because now what happens is 1/2. And you get all right. I'll let you guys dive into these.